All right, good morning. What are we in now? Week 13, is that right? 3 weeks, then finals, and then summer. All right, the what's due when? Let's take a quick gander. Week 13, we got a pretty straightforward week. Just 2 labs. Project 5, which is going to be essentially kicked off today, and really dig into it in detail on Wednesday. That'll be due early next week. I figured it takes a little bit to get your head around it. Once you get your head around it, there really isn't that much code to it. Yes?
Is project due next week Tuesday or 2 weeks from now Tuesday?
Oh, I'm sorry. That's a copy-paste error. I figured that Wednesday will probably be the day where any confusion as to how to implement it is resolved. We do some sequence diagramming and look at that. I'm sorry? No, damn it. See of course, this course show is copied from last semester, and last semester was the campfire, and that it's messed up the schedule at the end of the semester, so everything's off. All right. The 2 labs, directly, the code that you do in those 2 labs are directly plugged into your project. So, yeah, it's definitely to your advantage to do those labs. And not wait to the last minute since you're normally in the lab. Oh, today's lab I have to attend to something else, so I will not be in lab, but of course Jesse will be there, so should be in good hands. And I'll be talking in detail about reading from Delimited Files here in class, so you should be able to knock that lab out pretty easily, I hope. All right, so let me take a quick look at Project 5 then. Joust rears its ugly head once again. This one I wanted to cut more to the chase, so I dispensed with the emails and kind of the brainstorming at the beginning, get right to where we can start figuring out the design for the thing. So I did that for expediency reasons. You're going to go ahead and extend the Joust project, and the first is that you are going to read the information for both knights and their weapons from a file named joustdata.txt. So this is different from, I had promoted the idea during Project 4 that you use I/O redirection at the command prompt to save on typing. Something like that, so that you wouldn't have to type in the answers to those 10 questions. Now you're going to actually modify the code so that you open up a file and you read in data. So that'll be a little bit different. Each knight no longer has a single weapon, but each knight has 2 weapons. Your primary weapon and your secondary weapon. And each knight uses both weapons simultaneously. The knight's stamina is reduced by the sum of the staminas required of the 2 weapons. If either weapon hits, then the opponent is unhorsed. And then also the weapon is a little bit more complex in that each time the weapon is used, let me see, what were we using as for the name of the member function for weapon when you're figuring out if the weapon hit? Did I hit it? Okay. So each time then you interrogate the weapon, did I hit, there's a probability that that weapon's going to break. And that probability rises with each use. So the first time you use it, there's no chance of it breaking, but the second time it'll be a 20% chance of breaking, and so on up the scale. If a weapon does break, then the weapon's attempt to hit will fail. Now I'll concede that this isn't very realistic as far as knights jousting. If the knight's sword breaks at the hilt, they aren't going to furiously be pounding on the other knight with the hilt of the sword, wondering why it's ineffective. But by golly, this is my joust world, and my knights are actually that dumb. All right. The bottom line is it just keeps things simplified and codable. The more, as you can imagine, the more realistic you get, the more code that's required. Fallout 4, I imagine, required more than 100 lines of code. All right. So any questions on those requirements? All right. So again, on Wednesday, yes, go ahead.
Can we just take our previous weapon class and just update it?
The assumption is that you'll start with your previous class, your previous project. Yes?
And so we're just going to read up some files. We're not going to output the output?
Right. So the project 4 had the questions. What is the first knight's name? You don't ask any questions.
Okay.
You just open the file, read. Okay. All right. So let's talk about delimited files. Let's see, what shall we call this? Delimited data dot, I guess I'll do text. The extension, I don't know if I've mentioned this, but really the file extensions in Unix, Linux are relatively unimportant, meaning that that's a perfectly fine file name in Linux. The extension used tends to be used in things like web, and certainly you can take advantage of it, and by custom obviously you're going to name text file something like .txt, but I just want to emphasize that there's nothing in Linux itself that cares what you call the files, right? All right. So let's see, what shall we create data for? What's a mundane occupation?
Teacher.
Oh, okay. That's a good one. That's a good one. Teacher. All right. So every teacher has a name. Every teacher has a number of brats on his brat list. All right. Let's see, what else might a grade school teacher have? Number of confiscated items in the bottom right-hand drawer of the desk. All right. So that would be, that's right. Okay, let's go with that. The brand of liquid refreshment, we'll say that this person is going with Gatorade. And then number of confiscated, I got to write this down or I'm going to forget it. So Vim, notes, name, number of brats on brat list. You know that all grade school teachers keep those, don't you? the drink, and then number of confiscated toys, candy, anything that a child would love. All right, and we'll come up with another teacher's name. I think Ichabod Crane actually, wasn't Ichabod Crane a school teacher? I think so. This one, it's a parallel universe, and this is a kind-hearted Ichabod. And the drink would be, let me see, what's an old-timey absinthe? I'm not quite sure the spelling, we'll roll with that. And, of course, we'll just say an even 2. Took the 2 dolls from the twins in the back. All right, so let me grab this and let me start a C++ program. Let's call this read delimited data.txt. And I'll leave that up there. Oops, I lost my, and now I named that totally wrong, didn't I? Oh. Let's rename that to CPP. Let me actually rename it back. All right. So I want to move it. I can say move RE. On my command prompt, I've configured all of your prompts if you're on Jaguar, if you'd run my helper script to have Vim bindings on the command line. So I have tab completion here, so if I hit tab, that'll complete that. I want to rename that. I'll go ahead and do that again. Now it's just a matter of me hitting backspace and CPP. Then when I wanted to change it back, I hit escape. And then how do you go up in Vim? K. So I hit K, that goes up to previous commands, J goes down. Now I want to move forward by, there are a number of ways for me to do it. The easiest way for me to get over, I want to change text in CPP. The easiest way for me to get over there, well, I'll give a couple ways. I can hit W for word. Word, 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 that takes me there, right? That works. We'll just go with that. And then I type CW to change word, and I say CPP, then I hit escape, word, word, L, CW, TXT. Okay, so just showing you the potential once you get comfortable with Vim, how you can get a lot faster with stuff. Yeah, just leave it. All right. We want to create an input file stream. In order to do that, I have to !include the file stream. IOStream includes string, but I'm going to, I'll just include it specifically. Doesn't hurt. And then I have to give this variable a name. Generic input file. There we go. Now I need to open it. You can open it if you put the file you want to open up here, but you can also do it in 2 separate steps. I'm going to do it as a separate step in this case. Oh, this is too long. GIF, generic input file. GIF.open, and this file over there on the left pane is Delimited Data. The first thing I need to read is a string. Actually, what I'm going to do is I'm going to up the game again and do some error checking. So if this is, so that's the not or the negation operator. It's also a way to check if the file's in a good state or not. I'm going to be explicit about it. That's a little bit more readable. So the input file streams and output file streams have a member function called good. I can ask it whether it's good, and then I negate that. So for me to read it out loud, I would say if the input files, if the generic input file is not good, whoops, I lost a parenthesis, then I want to complain. And here's something we haven't seen before, I don't believe. Error. And then I'm going to exit my program. I'm going to come right back to all that in about 10 seconds. I'm going to finish up by saying that I want to close the file when I'm done with it. So we'll have a bunch of stuff right here. But looking at this right here, error is, anyone know what error is?
See out if there's an error.
Ah, see out if there's an error. Yeah, that's actually about right. So when you get to, I guess you learn it certainly before systems level programming, but at the systems level, whenever you have a program that's running, there are actually 3 streams associated. Whenever you do ls, that's a program that someone wrote at some point, by the way. Whenever you run ls, there are 3 streams. Whenever you run your program, there are 3 streams. This little program that's running that's giving me this prompt, there are 3 streams. Every program you ever run will start with 3 streams, and those are input, output, and error. Okay? Now, input under these normal conditions is coming from the keyboard, output is going to the screen, and then standard error is going to the screen as well. You can see that with ls. For instance, let me see. I can explicitly list 2 files. So I can say list delimited data.txt and list notes.txt, and then there they are. I can send that output, so I can say that I don't want standard out, or we've been calling it cout. Cout's just the name of a variable that is allowing us to write to standard out. I can redirect all of standard out to a file by simply using the greater than sign. And you'll note that we didn't see any output here because it was no longer going to the screen, it was going to FDSA. And in fact, I can look at FDSA and they're the 2 files that it listed. I can also make a mistake. Let me get rid of that. And I can list this file, which doesn't exist. And now ls is reporting an error. So the problem, if I did not have standard error, is that situation where I'm doing this right here, and what if I had an error and one of these files didn't exist? So let me do this. Then what would happen is that error message would go into FDSA, right? And so standard error is a nice way of writing information that you don't necessarily want to go to the same place as standard out due to things like errors. And now when I hit this, you'll note that the error did in fact go to the screen, and there's nothing, well, there's that in FDSA. So it listed the valid file, and then the invalid file it generated an error for. So that kept it separate. So yeah, so that's exactly what error is. Exit, as it implies, will leave your program. In fact, probably would be better since I'm in main, so I'll just say return 1. Another question is why 1? Can it be 99? Or how about 24? Yes, it can. When I do ls, this is the shell. What you're actually doing is you're returning this number to the shell, and then the shell can interrogate that. So when I do ls return to value. This $question mark is what ls returned to me. Now is 0. What if I do something bad? Now if I look at what ls said, ls gave me a 1. So there's a convention that whenever you write a program and it behaves correctly, you should return 0. Whenever you are exiting out for some sort of error, you should return some sort of non-zero number. So let me make this 9. I think that will compile at this point. Now, I don't have any errors in here. This is what's going to happen is it's going to open this file because it does exist. And then it's going to close, and it's going to quit, and we should get 0 back. And I did. But now, let me temporarily move. Let me go up here. Let me move this delimited data. Let me call it dd.text. Just get it out of the way. Now it's renamed. Now this should not open successfully, and GIF should not be good, and I should fall into this error code here. So let me try that. No, I didn't need to recompile, by the way. That was just habit. In general, you'd have a low number, 1. So 1 it is. So that's what's going on with that. That's all by convention. There's nothing syntactic requiring me to choose a particular number. And I haven't, it's almost beyond the scope of this class, but there's an electronic manual for all the commands you'd ever type and all the system calls you'd ever use, actually, in Linux. And you can get a manual page. The command is called man, so I can get a manual page on the ls command. And it gives me a summary, and it tells me all this information, and it gives me all these options. Somewhere, yeah, the ls utility exits 0 on success and greater than 0 if an error occurs. So the different commands will give you that kind of information, telling you the kinds of return. Sometimes they'll tell you it's going to be a 1 if this error occurred and a 2 if this other error occurred, that kind of thing. All right. So let's continue on writing this. Let's move dd.text. All right. The first thing I have to do is read in the teacher's name. I'm going to create a string. Call that tname. Tname. And then I will do a GetLine. GetLine from GIF or GIF. All right, now we get to this point. So what I have on the left here is what I've been referring to as a delimited file. What that means is that I have a particular character or a delimiter separating one piece of data from the next. And by convention, you normally choose a character that isn't likely to be found in the data. For instance, the letter A would be a poor choice for a delimiter. But it doesn't have to be this vertical bar, this pipe. It could be any character you want. GetLine, by default, will read up until it finds a new line character. And if you include nothing but those two arguments, then it will be assumed to be the new line character. You are allowed to provide a third argument, And if I wanted to do the exact same thing, it would look like that. So that's saying read up until I find a new line and gobble up the new line. In this case, we are doing that pipe character, so I'll put that there. That'll read up until the pipe right here. Let me get the number now. I'm going to read that in as a string as well. I'm going to create this kind of temporary holder variable that I'll reuse. GetLine. Up to pipe. All right. So input and output, I guess we'll just focus on input. Input tends to be pretty error prone, right? You try to read in a number, but it's not a number, and that causes the input stream to get all screwed up. It is far easier to read in everything as a string and then convert it if it's not a string. So that's what I've done here. Is on line 24, temp holder is going to hold the 32, but that's going to be as a string, meaning as that, right? You can't do arithmetic with that. That's just a sequence of characters. So this function converts it to an integer, and of course the STI means string to integer. So that's a nice built-in function, part of the standard that you can use for that. And then what do we have next? So drink. So string drink. Read that up to a new line, or to a pipe rather. I'll reuse the get line for as a temp holder. Reuse that string. Actually, I have a bug in my program. Let's print some output and get to the bottom of the bug. Cout teacher. First teacher is tname. List length equals let me actually just do that much for the moment to see. I should be compiling this more frequently. Whoops. Force of habit. That was the old, back in the Dark Ages version. All right, so far so good. List length, cout, drink, and then finally toys. And then I'll have an end line to end that. Do another quick test. That should look fine. Let me zoom in for a minute. All right, that all looks good, but I do have a bug in my program. Let's see if we can find the bug. I want to continue on with the next entry, the second entry. So I'll go ahead and I'll do a GetLine. Now I'm going to copy and paste here to save a little time. All right, let's watch the bug. So the second teacher picked up that 0, not Ichabod Crane. What's going on? What's the bug? Yeah,
You said to get from the
give me a line number.
from the end of line 1, or B for line 1. You said,
Oh, I mean,
oh, sorry. So on your line 35 on your code, you're saying that T name is up until the first line.
it is right here.
Yeah. So it would actually grab what's after that, because
You're exactly right. You're just at the wrong line number. Jump up to line 28.
yeah.
That's what where you want it. Okay, so what do I need to do to correct line 28?
I was gonna say just make another line on your text mode, but I don't know from there.
What's this line doing?
Going until the next vertical line. You don't need that. You need to the end of the one.
Ah, so this one's reading in. The intention is to read in 325 here, but we said to read up until you get to a pipe. So it's going to read the 3, the 2, the 5, the new line, all of this, and then it finds the pipe. So two things to look at. One is it's a reminder that you have to think about data in terms of just being a long stream of bytes. And if I do this, whoops, let me zoom in. Okay, this is the long stream of bytes. Note that visually now, there's no special treatment for the new line. It's just NL. It's just one of the characters all along, right? It's a character like any other. It has to be read in like any other. It can be treated like any other. It's visually appealing to us, of course, because it allows us to visually separate text. So that's one thing. The second is we can actually see that error in action. I can do, let's use our Sierra. We won't see any difference when we run it, but what I want to do is I'll create like this bumper here, and I'll create another bumper like that. Put a new line at the end of that. And between these two bumpers, I want to put temp holder. So let's see what was actually read in. Compile, run. And there you can see it read in the 3, the 2, the 5, the new line, the Ichabod Crane, and then it stopped. So I'll comment that out, and then the fix is to either change that to a new line, or, again, the default behavior of this is to assume it's a new line. So I could do it that way. Either way, it'd be fine. I think given that we're using an odd delimiter here for most of this, I think it's nice to be explicit and make that visual as we're casting our eyes through this. All right, so we just kind of repeat all this then. Let's see, where am I? And second teacher. I guess I can probably just straight copy most of this. I'll copy it, and there will be a little bit of an error. We'll see what the error is. Where am I at? I read the teacher name, so now I'm here on line 23. So I'm going to go lines 23 through 30, yank. And now I'm going to repeat this input code. But there's a bug here. Let me get rid of that. it isn't going to compile. We can see the compiling error, but does anyone want to hazard a guess as to why I'm going to get a compiling error? Yes?
You're redefining rats and toys.
There are variables that I have created here. I think I'm fine with that one because I did that manually. But temp holder, brats, drink, those are variables that have been created. I'm going to get an error if I recreate them. So let me just delete line 40. It's already created. We can keep using it. Brats has already been created, so let me get rid of. How can I fix line 41 so that I don't recreate brats?
Just delete it.
Yeah, just delete it. There we go. The existing variable brats, I'm going to assign that conversion. And then don't redefine drink. Don't redefine toys. And now I think I have all the data. Now I don't have any of the prints other than the second teacher. I'm going to put all that down here. There's no difference to the output yet, so I don't have the prints for the second teacher. So let me do other than, whoops. Oh, I didn't recompile. Yes, I did recompile. Did I not fix? I thought I fixed my problem. I didn't write out my changes. That was the issue. All right, so far so good. Let me do lines 32, excuse me, through 34, yank, come down to the bottom, paste. And there we go. Okay. So today's lab is to read in a delimited file that will be used to read in the knight and weapons for Project 5. So you should be able to use this as kind of a recipe to follow to get that lab done. All right. Any questions? Okay. Well, we can go ahead and break a few minutes early, and we will see you in lab. I'll only be there momentarily, as I said.